All right, welcome back. So what we're going to be doing now is instead of going through the trouble of plotting a whole bunch of points and then hoping that those points are enough to provide us with a good picture of, our graph, our equation, that we don't miss any important details with the points we plotted, we then instead we want to eliminate the parameter. We want to make it disappear and actually get an equation in x and y. And then from that equation in x and y, then we can try and use some of our knowledge of graphs and functions to be able to come up with a decent graph. So the simplest way to eliminate the parameter is when you can easily solve for the parameter in one of your two functions here. So here I can easily solve for t in that first equation, x equals t plus 2, by simply just bringing the 2 over and getting x minus 2 is equal to t. And then I can go to my other equation and express y now as the square root of x minus 2. Okay, so at this point, we know we're going to be dealing with the graph of the square root of x minus 2. We remember what the basic shape of the square root graph is. We remember what the basic shape of the square root graph is. Remember that's our kind of half of a C, half of a U. And if you looked at the graph, it's going up, half of it, it would be kind of half of the U shape, but it's just the top half. So that's the graph. Now, to graph the parametric equation, we don't know immediately which parts of this graph it's going to be. Is it going to be the whole graph? Is it going to be just parts of this graph? So what we generally will have to do at the very least, we're going to need to plot the t values, compute the t values, the x and y values for t at the first and last point in the interval, at the very least. But so we can really see what the direction of motion is, I usually like to also include something in the middle. So here I'm going from 0 to 4, so I might do like t equals 0, t equals 2, t equals 4, just so I can get a feel for where the graph starts, where the graph ends, and what direction of motion do I have. Okay, and so we go in to the original equations now. We're still going to compute a few points, but now we can be computing our points intelligently, knowing the shape that's going to underlie this. So we can go in and say, okay, if I plug 0 in for x, that would be 2. If I plug 0 in for y, that would be square root of 0. That would be the point 0. So we're starting at the point 2, 0, which is actually going to be this point right here on the graph. And then we plug in x equals 2. We'd have 2 plus 2 is 4. And then square root of 2. And then finally plug in 4. 2 plus 4 is 6. Square root of 4 is 2. Okay, so now armed with that information and the basic graph shape that we already know, we can go ahead and start to draw our picture, and then also indicate on that picture the orientation. So our graph is starting at x equals 2, and it's going to continue until x is equal to 6. The y values are going to range from 0 up to 2. So what do we have? We're here at 2, at 6, 2, and we know the basic shape is that square root graph shape. So it's going to be coming up and then slowing down. Okay? And the direction of motion is as we saw from left to right in this example. Okay, and so that's how we can graph these. We convert them over to x and y. Still going to have to plot a few points so we get a little feeling for the motion. But the x and y graph will have an idea of what our shape is. And then we graph it across our constraints. In this case, this t ranges between 0 and 4.